RL. In this learning session, we'll learn about quadratic equation and different aspects of quadratic equation. Before we proceed with quadratic equation, let us understand as to what is a quadratic polynomial. A polynomial of second degree is called a quadratic polynomial. For example, 3x square plus 2x plus 6 is a quadratic polynomial because it is a second degree polynomial. The general form of a quadratic polynomial is ax square plus bx plus c, where x is the variable, a is the coefficient of x square, b is coefficient of x, and c is a constant. Now, what is a quadratic equation? A polynomial equation of second degree is called a quadratic equation. That means algebraic equation or a polynomial equation in which the polynomial is of second degree is a quadratic equation. For example, same 3x square plus 2x plus 6, which is a quadratic polynomial, if I equate it to 0, it becomes a quadratic equation. The general form of a quadratic equation is ax square plus bx plus c equal to 0. Please remember, the general form of a quadratic equation is ax square plus bx plus c equal to 0. Remember that. Now, the next point of our study is the standard form of quadratic equation. A quadratic equation in which RHS is equal to 0 is a standard form of quadratic equation. For example, 3x square is equal to 2x minus 6 is definitely a quadratic equation because there is a variable with a second degree, that is power 2. Now, this is not in standard form because RHS is not equal to 0. But if I move 2x and 6 to the left side, then 3x square minus 2x plus 6 is equal to 0. 0 is on the RHS side, and therefore this is in standard form. This is the standard form of quadratic equation. Quadratic equations are expressed in standard form for comparison and solving. Remember that. Now, there are different types of quadratic equations. We have got adfected quadratic equation and pure quadratic equation. The adfected quadratic equation general form is ax square plus bx plus c equal to 0. It has variables of second degree as well as first degree. For example, 3x square plus 5x plus 6 is equal to 0 is an adfected quadratic equation because it has a variable of second degree and a variable of first degree. Now, pure quadratic equation is a quadratic equation in which there is only a variable with second degree. For example, ax square plus c is equal to 0 is a pure quadratic equation. It has variables with only second degree, and for that matter, in the general form of ax square plus bx plus c, if b is equal to 0, then it is ax square plus c equal to 0. It becomes a pure quadratic equation. So, an adfected quadratic equation becomes a pure quadratic equation if b is equal to 0. For example, 3x square plus 6 is equal to 0 because 5 here, b is 0, so it becomes 5x is 0, therefore 3x square plus 6 is equal to 0 is a pure quadratic equation. Remember that. The next important discussion is to check if any given equation is a quadratic equation. If that means if we are given an equation, now we have to check whether that given equation is a quadratic equation. Now, a quadratic equation must have a variable of second degree that is known to us. Now, simplify the given equation and compare with the standard form of quadratic equation. So, let us take an example and understand this. X plus 1 whole to square is equal to 2 in the bracket x minus 3 is an equation given to us. Now, we do not know whether it is a quadratic equation or not, but first we have to simplify this and write it in standard form. So, x plus 1 whole to square is x square plus 2x plus 1, and 2x minus 6 is when you apply distributive property and we get 2x minus 6 here. Then x square plus 2x minus 2x is equal to minus x minus 1, or x square is equal to minus 7, or x square minus 7 equal to 0. Now, if you see here, x square minus 7 is equal to 0 is a pure quadratic equation, and therefore the given equation is a quadratic equation. Now, the next important one more example we will consider. X cube minus 4x square minus x plus 1 equal to x minus 2 whole to cube. Now, x cube minus 4x square minus x plus 1 as it is I have written here. Now, I am using the x minus 2 whole to cube is a cube minus 3a square b plus 3ab square minus b cube. So, using that identity, I can open x minus 2 whole to cube as x cube minus 3a square is x square into 2 plus 3ab square, that is 3 into x into 2 square, and b cube. Then simplifying the RHS, we get x cube minus 6x square plus 12x minus 8, and x cube gets cancelled, and rearranging the term, that is bringing all the terms to the left hand side, we get 2x square minus 13x plus 9 equal to 0. Again we find that it is a second degree polynomial here, and after writing it in standard form, and therefore it is a quadratic equation. So therefore both the examples which we have considered, both are quadratic equation. So the procedure of finding out whether a given equation is a quadratic equation or not: so first of all, simplify the given equation, write it in standard form, and compare it with the standard form of quadratic equation, that is ax square plus bx plus c equal to 0. If it is a second degree equation after simplification, then it is 100% a quadratic equation. Remember that. Now the next important discussion is roots of a quadratic equation. The value of the variable which satisfies a quadratic equation or makes LHS is equal to RHS are called as the roots of a quadratic equation. Now roots are also called as the solutions. A quadratic equation is a second degree equation, and therefore it will have two roots. Remember that. A quadratic equation is a second degree polynomial equation, therefore it has two roots. Let us understand this by an example. Now if we are given a quadratic equation x square minus 3x minus 10 equal to 0, then if I put x is equal to minus 2, and then wherever x is, I put minus 2, I get 0, I get the value as 0. That means for x is equal to minus 2, the value of the polynomial becomes 0, or LHS becomes equal to RHS, and therefore x is equal to minus 2 is the root of the given equation. Also when I put x is equal to 5, then again we find x square minus 3x minus 10 is equal to 0, LHS is equal to RHS, that 0 is equal to 0, therefore x is equal to 5 is also the root of the given quadratic equation. That means the given equation x square minus 3x minus 10 equal to 0 has two roots, x is equal to minus 2 and x is equal to 5, and therefore the given quadratic equation has two roots. Remember that. That means the roots of a quadratic equation can be verified by putting a certain value of x in the quadratic equation, and if we get a 0 and if we get LHS equal to RHS, that 0 is equal to 0, then definitely that will be the root of the given quadratic equation. From this calculation we find that x square minus 3x minus 10 has two roots, and that is what is the answer for this. Now methods of solving quadratic equation. There are different methods of solving quadratic equation. We have got the factors method, completing the squares method, quadratic formula method, and the graphical method. So let us learn these methods one by one. Let us go for the factors method first. Now for example, we are given a quadratic equation here, 2x square minus 7x plus 3 equal to 0, and by factors method means since it's a trinomial, I can go for middle term splitting method, and by splitting them and converting it into tetranomial and again pairing and grouping them and taking the HCF common, I get two factors, x minus 3 and 2x minus 1, and I can equate it and is equated to 0. That means if LHS has to be 0, x minus 3 must be 0, or 2x minus 1 equal to 0, x is equal to 3 here, and 2x is equal to 1 or x is equal to half, and therefore the roots of the given equation 2x square minus 7x plus 3 are x is equal to 3 and x is equal to half. So that is the factors method of finding out the roots of the given quadratic equation. Remember that. The next important method is the completing the squares method, and this is a very important method, and please try to understand the procedure. Now let us understand this method with the help of an example. Now we are given a quadratic equation 2x square minus 7x plus 3 equal to 0. We have to find the roots by completing the squares method. Please understand, completing the squares method. So we have to complete a square, and let me make you understand as to what exactly it means. Now 2x square minus 7x plus 3 equal to 0. Now you see the coefficient of x square is 2. The coefficient of x square is 2, so make the coefficient of x square as 1. So make coefficient of x square as 1. To make it 1, I have to divide the quadratic equation throughout by 2. So I divide 2x square by 2, 7x by 2, 3 by 2, and then we find 2 gets cancelled, and we get x square minus 7 by 2x plus 3 by 2 equal to 0. Here we have the coefficient of x square as 1, and the coefficient of x is 7 by 2, minus 7 by 2. Now take the first two terms here, x square minus 7 by 2x. Now x square is a square term, minus 7 by 2x is also another term. But when we take a minus b whole raised to square, we get a square minus 2ab plus b square. So the first term is a square, so I have x square here. The second term is 2ab, I have that also. But the third term, b square, is missing there. So in these two terms, there b square is not there. Now to find out b square, what we can do is take the coefficient of x, that is minus 7 by 2, divide it by 2. Take minus 7 by 2 and divide it by 2 and square it. I get 7 upon 4 whole raised to square. So the third term is 7 by 4 whole raised to square. So what we can do is add and subtract the term, because we cannot only add, we have to subtract also, so the quadratic equation does not change. So 7 by 4 square minus 7 by 4 whole raised to square plus 3 by 2 equal to 0. Now these three terms form a square term. That means it is a minus b whole raised to square now, because this is a square minus 2ab plus b square. A minus b whole raised to square, a is x, b is 7 by 4, so a minus b whole raised to square. So I have converted two terms into three terms and converted into a square form, and that is what is the meaning of completing the squares method. So x minus 7 by 4 whole raised to square minus 7 by 4 whole raised to square plus 3 by 2 equal to 0. Transfer these two terms to the RHS. We get 7 by 4 whole raised to square minus 3 by 2. Simplify this, we get 25 upon 16. That means x minus 7 upon 4 whole raised to square is equal to 25 by 16. Now let us further simplify this. That means x minus 7 by 4 by taking the square root on both the sides, we get x minus 7 by 4 is equal to plus minus root of 25 by 16 plus minus 5 by 4, because square root of 25 is 5, square root of 16 is 4, so plus minus 5 by 4. That means x minus 7 by 4 is plus 5 by 4, and x minus 7 by 4 is also minus 5 by 4. Now taking this 7 by 4 to the right side, we get x is equal to 5 by 4 plus 7 by 4, and simplifying this, we get that x is equal to 3. That is the first root. Then on the right side we have x minus 7 by 4 is equal to minus 5 by 4, and transferring 7 by 4 to the right side and simplifying it, we get x is equal to half, and that is the second root. Therefore the roots of the given quadratic equation are x is equal to 3 and x is equal to half, and that is what is the completing the squares method. And this requires a bit of practice. Please practice this with more number of examples. Understand this example, practice this same example again and again, understand the method, and then try this method with other examples until you understand it. So that is what is the completing the squares method. Now the next method of finding out the roots of a quadratic equation is the quadratic formula method. Now for example, if ax square plus bx plus c equal to 0 is a quadratic equation, then x is equal to minus b plus minus root of b square minus 4ac upon 2a is a quadratic formula. Substitute the values of a, b, c in this, and then you will get the values of x, which are the roots of the given quadratic equation. This is what is the quadratic formula method, and this is the quadratic formula. So the quadratic formula is x is equal to minus b plus minus root of b square minus 4ac upon 2a, where b is coefficient of x and a is a coefficient of x square, c is a constant. Substitute the values in this and then get the roots of the given quadratic equation. But before I proceed with the application of this quadratic formula, let us derive this quadratic formula by method. We will derive this quadratic formula in our next learning session, and then proceed with application of the quadratic formula to find out the roots of the quadratic equation, and also we will learn the other methods and also other aspects of quadratic equation. Thank you.